I have three more quadratic word problems that I wanted to show you. They are a little more challenging. Oh, they're all similar, but what makes them challenging is that they don't give you one equation. So we have to write the function ourselves and work with it. So example 3, it says Lorenzo has 100 meters of fencing. What is he doing with this 100 meters of fencing? And he wishes to enclose a rectangular field. So let me draw a rectangle. Let that be his rectangular field. So it has 4 sides, right? Um, and he only has 100 meters to build this. Suppose that a side length in meters of the field is x. Suppose that a side. So what they are telling us that one of the side is x. And I'll just pick the random one on top and I call that x. But you know, you learned in geometry, opposite sides of a rectangle are congruent. So if the top is x, the bottom is also x. We know nothing about the sides though, okay? So because I don't know it, maybe I can just call it something. How about I just call it u for unknown? I just picked a random variable, u for unknown, okay? So I have two sides that are x meters long. Other two sides must be u meters long, okay? But we really don't need an additional variable in a math problem. So what my goal is, I want to rewrite this so that u is out of the picture and I only have x as my main variable, okay? So what do I know about this rectangle? All right, see if you agree with me. If I add up all these sides together, top plus bottom plus left side plus the right side, don't you think that will add up to 100, right? Because that's how much Lorenzo has. He has 100 meters and he's going to use every meters of it. So if you add up these four measures, it will add up to 100. This is 2x, this is 2u, and all that equal 100. And you know, all of them are even, so how about I divide all of them by 2, and I will get x plus u is equal to 50, okay? Which means u must be equal to 50 minus x. This unknown side is 50 minus x. So instead of writing u, how about I write down 50 minus x? How cool. What we just did was we labeled every single side of this rectangle in terms of x. So u is not there because, we're only going to write one equation, and one equation should consist of one variable, x, instead of x and u. So now what? If you want to check real quick, you can add these measures together. If you add x plus x, top and bottom, plus 50 minus x, plus 50 minus x, what will that be? Let's take a look. These two will add up to 2x. These two will come out. I will have 50 plus 50 adding up to 100. I will have negative 2x and negative x and negative x coming out to minus 2x. So x's cancel out and I will get 100. So yes, we got the measures right. But now what are we doing with this? Okay. Part A is asking you for a function that gives the area A of x, of the field in square meters in terms of x. Okay. Now remember area formula. Area is equal to, or I'll just say area equals of a rectangle, length times width. Okay. But look at our beautiful diagram right there. We already have length and width labeled. Okay. I can do the length times width right here. We can do x times 50 minus x, and that is the area of this rectangle. So I'll say I will do x times 50 minus x. This is fine. This is fine. We did x times 50 minus x. But if you may want to simplify this by distributing 50x minus x squared. If you even want to write this in standard form, I can say negative x squared first and then plus 50x. Okay, where a is equal to negative 1 and B is equal to 50. I'm just thinking ahead, okay? Because A and B will be very useful if we ever need to find the vertex, right? So both this is okay. That is both okay forms of equation. But just remember, rectangle's area is length times width. That's why we did x times 50 minus x. Now, what do they want for part B? What side length x gives the, what's the keyword? Maximum area. So we know this graph will open downward because A is negative. So it will definitely have the highest point. Because if a parabola looks like that, opening downward, the vertex is where we have the maximum. So whenever they ask you to find the minimum or maximum, find the vertex. Find the vertex. And they did specifically ask for the x value, which is one side of the rectangle. So let's do the vertex formula. X equals negative b over 2a. We said b is 50. The top of the fraction is negative 50. We have a is negative 1. So if you simplify that, we have negative 50 divided by negative 2. And it comes out to be 25 meters. So what we know is this. If I borrow or if I copy Lorenzo's rectangle down, let me duplicate this and put it down. I just found out that x is equal to 25. So I'm going to go ahead and say x is 25 and 25 here. 25 meter. But what about the other side? The other side, if I plug in 25, I will get 50 minus 25. Oh, look at that. 25 minus 25 is 25 too. Oh, wow. And do you know why I'm going, oh, wow? Because we found out that to maximize the area, this rectangle better be what? A square, right? So my diagram is a little bit off. I should have probably, I mean, back then I didn't know that it had to be a square. But after finding out, we got that the rectangle has to be a square if you want to maximize the area, because all sides are congruent, 25, 25, 25, 25. And if it's a rectangle, all angles are 90 degrees. So we're looking at a square field. All right, what do they want for part C? What is the maximum area of the field can have? Well, the maximum will happen if all sides are 25 meters, and we know how to find the area of a rectangle. Area is length times width. So if I do 25 times 25, that will be 625 square meters. So I did it by actually figuring out the dimension of this rectangle, but you don't have to do that. We have an area formula, a of x, which we found above. So if you want to plug in 25 there, and let us do that. Let's see if we get the same thing. What's a of 25? I have to do negative 25 squared plus 50 times 25. I want to see that this also comes out to be 625. All right. I'll just use my, I should probably go to this most scientific. All right, I'm typing in negative 25 squared plus 50 times 25. And look at that, that also comes out to be 625. So plugging it into the area function that we wrote in part B is perfect. But I wanted to just draw the diagram, figure out the dimension, and use the geometry formula. Both ended up with the same answer, so it's your choice, okay? So that was Lorenzo's word problem on maximizing his rectangular field. How is time? It's only 10 minutes. How about I do one more, okay? I'll do another one down here. Oh, this time Mohammed is building a fence. He has a little more. He has 500 meters of fencing, and he wished to form three-side of rectangle. Hold on a second. Three-side of rectangular field, but a rectangle has four sides. So what is happening? I mean, I'm going to try to draw a rectangle here, but rectangle should have four sides. So how come he's only building three sides? The fourth side borders a river. Oh, and will not need fencing. So I guess he's trying to put some cows in this field or something like that. And he knows that We don't need fencing on the fourth side because there is river. Okay, so only these three sides are what we need to fence. Okay, suppose that one of the side has length x. So I'll call this side x, okay? And I'll also call this side x, okay? I don't know what the top is though. And I cannot assume that it is x because this situation is a little bit different. Remember the previous one? When we did our work, it came out to be all same on four sides. But, you know, with us having this river on the fourth side, you know, the top side may be different. So for right now, let me call it u for unknown, okay? So this is what's happening. If I add up all the sides together, x plus u, I will get 500, right? Because Muhammad had 500 meters of fencing. So if I add up these three side length together, it better come out to be 500. We're trying to use every meters of it. So that is 2x plus u equals 500. If I want to solve this for u, I will subtract 2x from both sides. So u must be equal to 500 minus 2x. So at this point, I'm going to go ahead and erase the letter u and call this side 500 minus 2x. And you can check this. If you add up these three sides together, notice that you will get 1x and another x adding up to be 2x. But that positive 2x will get canceled out with this negative 2x. The only thing that we have left is 500. So they truly add up to 500 together. Now I have a feeling they're asking for an area. Part A is asking, find a function that gives the area A of x of the field in square meters in terms of x. Okay, you know that area is equal to length times width. We have those measures. We're going to do x times 500 minus 2x. And that is perfect. You can stop there. But I like to put this in standard form. By distributing, I get 500x minus 2x squared. And if I switch the order, I will get minus 2x squared plus 500x. And I'm going to identify what my a is and b is, because a's and b's are needed to find the vertex. Look at the next part. What side length x gives the maximum area? Maximum happens at the vertex. So we're going to find the vertex. Vertex formula is negative b over 2a. And b is 500, so negative 500 goes on top. We do 2 times negative 2 in the bottom. So I have negative 500 divided by negative 4, which is 125. I should check that, right? All right, what is, I wonder if this little calculator will show up. Oh, here it is. I can do 500 divided by 4 real quick, and that is 125. So if one of the side is 125 meters, let me go ahead and label this though, okay? I'll copy this picture, copy this down here, and tell them that we just found out that x must be 225. So I'll get rid of the x and say this is 125 meters. And this side is also 125 meters. What about the longer side? I say longer side because I put it longer, but it may not be long because my picture wasn't drawn to scale. So if I plug in 125 there, I will get 500 minus 2 times 125, which is 500 minus 250, which is 250. So this side is 250 meters. Okay? All right. So if they ask you for the maximum area that the field can have, I have the dimensions when that will happen. All I need to do is find the area. Area is equal to length times width. And the length is 250. And the width is 125. So if I multiply them, 250 times 125, the area comes out to be, wow, that's a big field. 31,225. 31,200, oh goodness, my memories. 250. 250 square meters. So that is the biggest area Muhammad can build his rectangular field along the riverside, okay? But what if you wanted to use that function, okay? Because we should get the same answer. What I'm going to do is I'm going to plug in our 125 into that function that we wrote, okay? The function says when you plug in 125, you will get -2 times 125 squared plus 500 times 125. I want to see if this comes out the same as 31,250 meters. Let us see. And for that one, it's a multiple operation. I'll go ahead and use a scientific calculator, okay? Okay, so I'll go ahead and do -2 times 125 squared plus 500 times 125. That came out to be all the same measure. So I think we did it right. This is perfect. And that's been almost 17 minutes, so I will stop this video now. I showed you 2 examples of a word problem, 2 people building fences, how we can write the area function as a quadratic function, and find the x-coordinate and the y-coordinate, which means the dimension and the maximum area for each field in this video, okay? All right, I'll be back to do the very last one soon.